morning student, how are you? In previous video we study up to exercise 2.3 at question number first. Now we are in question number second, and to solve this whole exercise we have used remainder theorem. Now the question number 2. In question number 2, when find the remainder when this polynomial is divided by this. Okay, we have to divide this polynomial means x cube minus x square plus 6x minus a by x minus a. Okay, according to the remainder theorem, if we divide any polynomial p of x with x minus a, then remainder is p of a. It is a remainder. Do you know remainder theorem? This is the remainder theorem. We didn't get any idea about quotient. Okay, we can find only remainder by using remainder theorem. So it is a linear. It is a linear. The dividend is a linear, so we can use remainder theorem. Now I have to divide this polynomial, so the value is p of x is equal to x cube minus x square plus 6x minus a, and I have to divide this polynomial by x minus a. Then what is the remainder? P of a. Okay, so I have to put the value of x is equal to a. Here is negative a, so I have to write here positive a. So I have to put the value of x is equal to a. So a cube minus a into x square means a square plus 6 into a and minus a. If it the simplification of this, then we have a cube minus a square into a, we have a cube, plus 6 into a, we have 6a and minus a. Okay, now it is a positive a cube and it is a negative a cube, so both will be cut. 6a minus a, these both are similar terms, so 6a minus a, we have 5a. Okay, so 5a is a remainder when this polynomial, when p of x, this polynomial is divided by x minus a, then remainder is 5a. Okay, any doubt in this question? Now question number 3. What is in question number 3? We have to check whether that 7 plus 3x is a factor of 3x cube plus 7x. We have to check that the 7 plus 3x is factor or not. We can check by doing actual division, but it is a linear, so I do not want to actual division. This sum is easy by using remainder theorem. Okay, so I have to say this polynomial with p of x. Okay, so p of x is equal to 3x cube plus 7x. Now what is the value of x from this? We have to find the value of x. Okay, 7 plus 3x. Here is the 7 plus 3x. 7 plus 3x. So I take is equal to 0. So I can find the value of x. So 3x is equal to minus 7. So x is equal to minus 7 by 3. It is the value of x. Now x is equal to minus 7 by 3. I have to put this value in this. Okay? Okay, let p of minus 7 by 3 is equal to 3 into x cube plus 7 into x. Now the value of x is what? minus 7 by 3. I have to put the value of minus 7 by 3. Okay, now 3 here, minus cube. Minus cube is minus 7 cube. 3, 4, 3 and divided by 3 cube. So here we have 27 plus minus 7, 7 the 49 and divided by 3. Now this 3 is cut with 27. 9, 3 is 27. So we have minus 343 divided by 9 minus 49 divided by 3. If we take LCM or same numerator, here is 9, here is 3. So by taking LCM, we have here is 9. Okay, so we have minus 343 into minus 49 into 3. Okay, it is the LCM. Now minus 343 minus 49 into 3, we have 147 and divided by 9. So the answer is, if here is sign negative, here is sign negative, so we have to do the addition of these both. Okay, so the addition is 490 and divided by 9. Here we got this remainder. This remainder is not equal to 0. The remainder is not equal to 0 means that 7 plus 3x is not factor of this polynomial p of x. Okay, if we find the remainder 0, then it is factor, otherwise it is not a factor of the polynomial. Okay, now we have to discuss about exercise 2.4. Now exercise 2.4, question number first, we have to determine that we have 4 polynomials are given, and from this 4 polynomial, which polynomial has x plus 1 is a factor. Okay, now here the first polynomial x cube plus x square plus x plus 1. So it is p of x. It is a p of x is equal to x cube plus x square plus x plus 1. Now here is x plus 1. Okay, I have to decide that it is a factor or not. So I have to put, here is plus 1, then here is minus 1. So we have minus 1 cube plus minus 1 square plus minus 1 and plus 1. Now minus 1 cube we have minus 1, minus 1 square we have plus 1, plus minus minus, and here is plus 1. So the remaining answer, minus 1 plus 1 cut and minus 1 plus 1 cut, we have answer is 0. So we have remainder is 0. It is a remainder is 0. So we can write x plus 1 is factor of p of x. Get it out? We can decide this by, we can do the actual division to find that x plus 1 is factor or not. Now second question, it is a p of x is equal to x raised to 4 plus x cube plus x square plus x plus 1. Now the value of x plus 1, so we have the value of x is minus 1, so we have to write minus 1 raised to 4 plus minus 1 cube plus minus 1 square plus minus 1 plus. Now minus 1 raised to 4 we have plus 1. Minus 1 cube minus 1 and minus 1 into plus, so we have minus 1. Now minus 1 square become plus 1 plus minus minus 1 and last 1. Okay, so this and this cut, this and this cut. The answer is 1 is not equal to 0. Here the remainder is not equal to 0. So we can say that x plus 1 is not factor of p of x. In similar way, we can calculate question number 3rd and 4th. Look into the question number 3rd. We have p of x is equal to x raised to 4 plus 3x cube plus 3x square plus x plus 1. Now p of minus 1 is equal to minus 1 raised to 4 plus 3 into minus 1 cube plus 3 into minus 1 square plus into bracket minus 1 and plus 1. Now if we do the simplification, minus 1 raised to 4 become plus 1. Now plus 3 into minus 1 cube is minus 1 plus 3 into minus 1 square is plus 1 and plus minus minus 1 and plus 1. If we send simplification, then 1 plus minus minus 3 plus 3 minus 1 and plus 1. So this one cut, 3 and 3 cut, we have 1 is not equal to 0. Here the remainder is not equal to 0. It means that x plus 1 is not factor of p of x. Now in question number 4. Question number 4, p of x is equal to x cube minus x square minus into bracket 2 plus root 2x and plus root 2. Now the value of x, we have to write p of minus 1. So we have minus 1 cube minus minus 1 square minus 2 plus root 2 bracket over here is into bracket minus 1 plus root 2. Now give your attention carefully. Here is minus 1 cube minus 1. Here is minus 1 square plus 1 and plus 1 into minus. So we have minus 1. Now minus plus. So we have plus 2 and plus root 2 and plus root 2. Okay, minus 1 minus 2, minus 2 is cut with this plus 2, so this whole cut, root 2 and root 2 we have 2 root 2 is not equal to 0. So we can say that x plus 1 is not factor of p of x. Okay, so we can decide this x plus 1 is a factor or not by this method. Also we can decide that addition of coefficient of the odd power term is equal to the addition of coefficient of even power term. If these both are equal, then also one factor is x plus 1. So we can calculate this whole sum by the method of how we can decide x plus 1 factor or x minus 1 factor. Okay, we also discussed this concept in theory. Now, question number 2. In this question, the instruction is by using the factor theorem, we have to decide that the p of x is a factor, g of x is a factor of p of x or not. We have to calculate this sum like first sum. Okay, there is no changing any method. Here, the p of x is given and g of x is given. Now we have to check whether this g of x is a factor of this or not. Okay, so how we can determine? Here p of x is equal to this. Now g of x is equal to x plus 1. Here is plus 1, so I have to check by p of minus 1. So we have 2 into minus 1 cube plus minus 1 square minus 2 into minus 1 and minus 1. So the answer is 2 into minus 1 cube means minus 1 plus minus 1 square is only 1, minus minus plus plus 2, and here is minus 1. Now 2 into minus 1, so we have minus 2 plus 1 plus 2 minus 1. This plus 1 minus 1 cut and minus 2 plus 2 cut, the answer is 0. Here the remainder is 0. So we can say that g of x is factor of p of x. Okay, now in second question, this is our p of x and it is our g of x. Now x plus 2, the value of g of x is x plus 2. So I have to write here p of minus 2. So we have minus 2 cube plus 3 into minus 2 square plus 3 into minus 2 and plus 1. Now minus 2 cube we have minus 8, minus 2 square plus 4, 4 3s are 12, 3 2s are minus 6, and here is plus 1. Okay, now 8 minus 8 and minus 6, we have minus 14 and plus 12 and plus 1, so we have plus 13. The answer is minus 1 is not equal to 0. The remainder is not 0. So we can say that g of x is not factor of p of x. Okay, if remainder is 0, then it is a factor, otherwise it is not factor. Now question number 3, we have p of x is equal to this and g of x is equal to x minus 3. So I have to put here p of here is minus 3, so answer is here plus 3. So 3 cube minus 4 into 3 square plus 3 and plus 6. 3 cube 27, 3 square 9, 9 4s are 36 plus 3 and plus 6. Now 27 and 3, 30, 30 plus 6, 36. So we have 36 minus 36. The answer is 0. Here the remainder is 0. So we can say that g of x is factor of p of x. Okay. So here we use the factor theorem, that how we can decide that g of x is a factor or not. Now question number 3. In this question we have to find the value of k, but the condition is given. The condition is that x minus 1, this x minus 1 is factor of this whole 4 polynomial. This is the condition given. X minus 1 is a factor of this whole polynomial. Okay, it is given in our data. So we have to find the value of k. Now, if this is the factor of this polynomial, then remainder is 0. Okay, we know this theorem very well. Remainder is 0 if this is a factor. It is a given. Okay, so I have to take the value of p of x is equal to 0. So here give your attention x minus 1. So I have to write p of 1. Here is minus 1, so here is plus 1. And remainder is 0. Understand? So the value of p of 1 is equal to 0. It means that I have to put here is 1, 1 and k, then we can find. So 1 square plus 1 plus k is equal to 0. 1 square 1, 1 plus 1 2. So 2 plus k is equal to 0. If k is the subject, then we have k is equal to minus 2. Okay, so we can find the value of k. Here the important thing is that the remainder is 0 because x minus 1 is factor of this. In this 4 question we have to take p of 1 is equal to 0. Also we have to take P of 1 is equal to 0. Also in this question P of 1 is equal to 0. Okay, we have to start this whole question by this because the factor is x minus 1. So P of minus 1, so here is plus 1 is equal to 0. Remainder is 0. Now second question, here I have to put the value of x is equal to 1 in this polynomial. So we have 2 into 1 square plus k into 1 plus root 2 is equal to 0. 1 square 1 into 2 into k into 1k plus root 2 is equal to 0. So if k is the subject, then 2 and root 2 becomes minus 2 and minus root 2. This is the value of k. Okay, now third question, P of 1 is equal to 0. It means that k into 1 square minus root 2 into 1 plus 1 is equal to 0. So 1 square 1 into k minus root 2 plus 1 is equal to 0. If k is the subject, then minus root 2 becomes plus root 2 and plus 1 becomes minus 1. So it is the value of k. Now fourth question, P of 1 is equal to 0. It is given. So the value of x is 1. So k into 1 square plus minus 3 into 1 plus k is equal to 0. So k square minus 3 plus k is equal to 0. Here we have k square. If we rearrange, k 1 square into k, so k plus k 2k minus 3 is equal to 0. So 2k is equal to 3. So k is equal to 3 by 2. It is the value of k. Thus we can find the value of k if this condition is given. It may be possible that here is x plus 2 or 3. If here is x plus 2, then here is P of minus 2 is equal to 0 if it is a factor of P of x. Okay, so we can calculate this term like this way. If you practice it, then you can find easily that how you can understand. Okay, now in next video we continue with question number 4 of this exercise. Up to that, stay with connected me with. Okay, goodbye.